In this video, we will learn how oxygen is made artificially, how it is stored and how it is transported. The whole process is like this. At first, air is sucked inside a compressor. There's a filter before that, so that there are no impurities like dust particles. If you look inside a compressor, there are two valves. The inlet valve sucks air in, and then with the help of a piston, the air is compressed to a very high pressure. The compressed air is then released through the discharge valve. One thing that you have to understand is that when air is compressed, it heats up. Because when you pressurize a gas by compressing it into a container, you're putting all those molecules into a smaller volume of space, and you are adding potential energy by the compression. Then when you release that gas back to atmospheric pressure, that energy has to go somewhere. So it's given off in the form of heat. That means the air that is released through the discharge valve is a warm air. Now this warm compressed air needs to be cooled. For that, it is passed through a freezing unit. And that is done with the help of liquid nitrogen. Liquid nitrogen is very cold. It can freeze anything instantly. Here you have to understand that liquid nitrogen is not mixed with the compressed air. Rather, the discharge pipe through which the compressed air flows out, that pipe is covered with coil tubing. Liquid nitrogen is pumped into that coil tube, which is in direct touch with the discharge valve, through which compressed air is flowing out. After coming in touch with liquid nitrogen, the compressed air becomes cold. The temperature falls down up to -200 degrees Celsius. The cold compressed air is then sent to a separator. Here carbon dioxide is separated as dry ice. The air that is now free from carbon dioxide is sent through an expansion turbine, where the air is allowed to expand. Here the air turns into liquid. It is called liquefied air. Its temperature is around -200 degrees Celsius. In the end, liquid air is sent into an air distillation column, where it is slowly warmed up, because it then separates various components of air like nitrogen, argon, oxygen, etc. As you may know, air is a mixture of different gases. So in this air distillation column, different gases that are present in the air is separated by slowly warming up the liquefied air. Nitrogen gets separated first, because nitrogen boils around -196 degrees Celsius. After that, argon gets separated, because argon boils at -186 degrees Celsius. Oxygen, which has a higher boiling point, is left behind and is collected separately. Now please don't get confused, because -196 is much more cooler than -186. Oxygen boils around -182 to -185. So if you look at these three temperature, obviously -185 is higher compared to other two. That means oxygen has higher boiling point. At the bottom of the air distillation column, you will see liquid oxygen settles down. Argon gas is sold for industrial use, particularly in the iron and steel industry, for welding and casting. Nitrogen gas is used to make fertilizers and food packaging industries. So basically from this entire process, in the end you will get liquid oxygen. Liquid oxygen is then transported by filling it into special containers such as aluminum cylinders. If it is required in larger quantities, then cryogenic containers are used. So always remember, oxygen for industrial use is delivered to customers in liquid form, and they are stored in cylinders and tanks at high pressure. It is said that the pressure at which liquid oxygen is stored in a container is up to 3000 psi or 200 bar. For those of you who don't know what is 3000 psi, psi is a unit of pressure expressed in pounds of force per square inch of area. In layman's term, anything more than 1000 psi is a lot of pressure. When you give your car for cleaning, you will notice they clean your car with high pressure water spray gun. With that much of pressure, you can easily clean all the dirt from your car. Anyhow, liquid oxygen is stored in the cylinders at around 3000 psi. These cylinders come with pressure regulator that allows you to set the output pressure. A patient in hospital needs around 50 psi, which allows low supply of oxygen. Oxygen cylinders come in different sizes and can be pretty heavy. The largest size is around 1.5 meters tall and contains over 7,800 liters of liquid oxygen. Today, a patient in a hospital can require up to 130 liters of oxygen per minute. That means a large cylinder would last about an hour. Now, cryogenic oxygen tank looks like this. They come in different capacities from 3016 liters to 61,620 liters. The Indian Air Force has airlifted 4 cryogenic oxygen tanks from Singapore in C-17 aircraft. Apart from Singapore, India is also looking at lifting oxygen tankers from UAE. The reason these tanks are called cryogenic tanks is because the term cryogenic is used for anything that is produced or stored below the temperature of -150 degrees Celsius to absolute zero. Absolute zero is referred to as minus 270 degrees Celsius. The reason it is called absolute zero is because no object in this world can be cooled below minus 270 degrees Celsius, because it is believed that there is no heat energy left in a substance below this temperature. As per the laws of thermodynamics, absolute zero cannot be reached. Anyhow, the meaning of the word cryogenic is anything that is produced or stored below the temperature of minus 150. Since liquid oxygen is formed at minus 185 to minus 182, that is why these large oxygen tanks are named as cryogenic oxygen tanks. I hope you found this video informative, and I'll see you in the next one.